All right, guys, here is part 2. Sorry, we got cut off right in the middle of that last one. But we were looking to find the perimeter of this shape, and we had to think about what do we know and what don't we know. And we had to use a little bit of problem solving in the Pythagorean theorem to find our missing sides before we could calculate the perimeter. Let's look at another shape here. All right, we've got Sam cuts grass at 10 cents per square meter. How much does Sam earn cutting this area? So this is a yard that Sam has cut, and we know that we are talking about area because of this square meters here. Okay, he's not just cutting around the outside of this yard, he's got to cut everything inside as well. So that tells us we are dealing with area. Again, we've got an odd shape here, so we've got to think about what do we know and what do we need to find out. So I know that there's not a formula that I can use to figure out this odd shaped area here. But when I look at it, I see that I could cut this into, break this apart into a square and a triangle. And I know how to find the area of a square, and I know how to find the area of a triangle. So if I can find the area of those two individual parts, when I add them together, I'll have my total area. All right, so let's start with the area of this square. We know square is just base times height, and since a square, all sides are the same. In this case, we've got 20 times 20. So the area of our square will be 20 times 20, 400 again, meters squared. 20 times 20 is 400, and m times m is m squared, so 400 meters squared. That's our first part. I'm going to write that here. To find the area of a triangle is just base times height. We cut it in half because it's half of the square. Now I know my height is 14, and even though the base is not printed right here, I know the base. Because of this part being a square, we know square all sides are the same. So if this is 20 and this is 20, then this side also must be 20, and that just happens to be the base of my triangle. So we've got 1/2 of 20 times 14. And remember, we can multiply in any order, so I could take 1/2 of 20 first, and that would be 10, and then multiply that by 14, or I could take 1/2 of 14 and then multiply that by 20, or I could do 20 times 14 and then cut it in half. Regardless of how you multiply, you get 140 meters squared. So again, I'll write that. I like to write it in my diagram, my picture, meters squared. And then to find our total area, we add that all together. Our total area is 540 meters squared. But the question was, how much does he earn? So if he's earning 10 cents per square meter, okay, per is our multiplication division word here. So we need to multiply that at times 10 cents. So 540 times 0.10 gives us $54. I know that's cut off there at the bottom of the screen, but 540 times 0.10 is $54. $54 to cut that yard, not bad. Now let's talk about perimeter and area of some non-polygon shapes and look at a circle here. Now, for circles, we come up with we've got some other vocabulary that we need to know. The perimeter of a circle has its own special name. It's called the circumference. It's the area around the circle. Again, the outside edge of that circle. And in order to calculate the circumference of a circle, we need to know the radius. The radius is the distance, that's a straight line from the center to the edge. We talked about when we have to make the circle in our soccer field, I've got to know that the radius is 30 feet, and I've got to use that to draw or paint this perfect circle around the middle of our soccer field here. So we've got to know the radius of our circle in order to calculate the circumference. Circumference is just 2 pi times the radius, or 2 pi radians. This pi is not a variable. Remember, pi is a number. It's 3.14159, yada, yada, yada. It keeps on going. So it is a specific number, but because there's no way for us to possibly write the entire number, we use this symbol to represent the number. But it's not a variable. It does not change. And when you are calculating circumference, you can just either leave the pi there, or if you have to round to the nearest decimal, use your calculator. All right, let's go ahead and find the perimeter of this shape using all of our different perimeter formulas here. We do need to find the length of the arc first using half the formula for the circumference. Right, so if we're finding the perimeter, we know we need to add up all the sides, right? So I know this side is 6, which means that tells me this side is also what? Hopefully 6. You can see that this is kind of like a rectangle, but it's got part of it kind of cut out, like somebody took a bite out of it or something like that. But this is 6 and this is 6 here. All right. We know, we can see here, that this is half of a circle. So if we found the circumference for the whole circle and then cut it in half, that would tell us the length of this arc. Right? To find the circumference of a whole circle, it was 2 pi radians, or 2 pi times the r. And then to find half a circle, we just cut that in half. Right? So 1/2 of 2 pi r, or 1/2 of 2 pi times 4. If we plug that into our calculator, again, because we're using pi here, we're going to get approximately 12.57, and our unit of measure is inches. So this is 12.57 inches. That's our arc. Okay. If we wanted to find the perimeter of the whole shape, we would need to know the length of this side. Well, this radius can actually help us, because from here to here is 4. That means from here to here is 4. And here to this edge of the circle is also 4. So based on that, if we know this distance to here is 4 and this distance to here is 4, from top to bottom, we know that this shape has a length of 8 inches. And now we can find the perimeter. We've got 12.57 for the arc, plus 6, plus 8, plus another 6. And when we add that together, we get 35.43 inches. Again, this is saying approximately because we did have to round here because of pi. And if we wanted to find the area of the shape, even though we're not being told to find the area of this shape here, it's going to be a little bit more work because we do have this round part. We haven't learned about the area of circles. Going back to our previous slide here, if we wanted to find the perimeter of this shape, again, we would need a little bit more information here. We would need to maybe make a right triangle here and use the Pythagorean theorem to find this side and this side. We don't quite have enough information just yet to find that perimeter. All right, so we'll talk about more about how to find perimeter of shapes like that in the class, and also how to find perimeter using circles and half circles. We won't get to area of circles just yet. That's coming in the future. All right, so today we use proper names of quadrilaterals. So we reviewed all those proper names. We looked at our quadrilateral family tree and the properties of quadrilaterals. We use those properties to determine missing angle measures, to find the area, and to find the perimeter. Remember that a quadrilateral's angles always add up to 360. Area of a quadrilateral, or a complex shape, is going to be dependent on the shape, and perimeter, we just add up all of the sides. And sometimes we have to do a little side work to find some of those missing sides before we can add them all up. Make sure you write down any questions that you guys have, and I'll see you next class.